Hello students, in this video we are going to study common types of organic reactions. So let's start. All type of organic reactions are broadly classified into 8 types. First is substitution reaction. Second is adhesion reaction. Third is elimination reaction, polymerization reaction. So these are the broad classifications of all types of reactions shown by the organic compound, which are first substitution reaction, adhesion reaction, elimination reaction, rearrangement, condensation reactions, isomerization reaction, pericyclic reactions and polymerization. So let's start with substitution reaction. Substitution reaction takes place when there will be a replacement of atoms or group of atoms within the molecule by another atom or group of atom without any change in the rest of the molecule is known as substitution reaction. The attacking reagent will be named as a substituent. On the basis of the attacking reagent, that is substituent, the substitution reaction is divided into 3 types. First is nucleophilic substitution reaction, second is electrophilic substitution reaction, and third is free radical substitution reaction. In this, the attacking reagents are either nucleophile, electrophile or free radical. So let's start with nucleophilic substitution reaction. So first is nucleophilic substitution reaction is generally observed when the nucleophile, electrophile or free radical is attacking on the alkyl halide. Okay? So first is nucleophilic substitution. As you can understand with the term, in this there will be the involvement of nucleophile takes place. Okay? So this is known as nucleophilic substitution reaction. Example, okay? Methyl chloride is reacting with the nucleophile, that is OH minus. There will be a formation of the product will be methyl alcohol and removal of Cl minus. So this will be behaving as a substrate. This is the substituent, which is a nucleophile. Okay? This is a strong nucleophile. A strong nucleophile. This is referred as a leaving group. And the strength of this nucleophile is greater than this Cl minus. Because of that, this nucleophile is replacing Cl, chlorine. Okay? This depends upon the strength of nucleophile which is attacking. Because of that, this substitution is occurring. So the mechanism which is followed in this reaction, so the nucleophilic reaction is of 2 types. So these are 2 types of nucleophilic reaction which is occurring in alkyl halides. So the full form of SN1 reaction is substitution nucleophilic. This one represent unimolecular. And second is substitution nucleophilic. This 2 represent bi molecular. So first is SN2 reaction or SN2 substitution reaction. In this, the full form is substitution nucleophilic bimolecular. Okay? So the characteristic of SN2 reaction first is, this is concerted reaction. Okay? What do you mean by concerted reaction? It means it is occurring in single step. Second property B, the rate of reaction. So rate of reaction depends upon both the reactants, that is alkyl halide and nucleophile, which is OH minus. See, there will be inversion of configuration will be taking place. There will be inversion of configuration will takes place. Okay? So I will explain it to you by the help of example. Fourth D, there will be formation of transition state. This reaction is accomplished by the formation of transition state. In transition state, there will be the bond length which are longer than the normal covalent bond. Because of that, this transition state is highly unstable. So these are the characteristic of SN2 reaction. Example, these reactions are generally occurring in alkyl halides. Nucleophile is OH minus. This is three-dimensional structure. So this nucleophile will attack from the back side of this molecule, ठीक है, not from the front side, it will attack from the back side, which will lead to the formation of transition state. So this is transition state in which the bond length which is represented by this faded line is longer than the normal bond length. Because of that they are highly unstable. So this is a slow step. So the reaction will further occur very fastly because the transition state is highly unstable. So it will form this is methyl alcohol and removal of Cl minus will be taking place. This is leaving group. So as you can see in this case there is a change in configuration. Okay? In this case there is chloride in this side whereas OH minus in opposite side in the product. So there is inversion of configuration is taking place. This is known as inversion of configuration. This reaction is occurring in the single step. So this is known as concerted reaction, and the rate of reaction is dependent upon both the substrate and the nucleophile, and this reaction is occurring in the single step. Okay? So there is inversion of configuration is taking place and the transition state formation is also taking place. So the full form of SN1 reaction is substitution nucleophilic unimolecular. This reaction is occurring in two steps. So the characteristic first, this reaction is occurring in two steps. ठीक है, two steps में हो रही है. ठीक है, whereas SN2 reaction was occurring in one step. B, the rate of reaction depends upon only substrate. Where is an SN2 reaction, the rate of reaction is dependent upon both the reactant, that is substrate and nucleophile. Third, C, there will be formation of reactive intermediate instead of transition state. Reactive intermediate is forming, which is carbocation. D, there will be retention of configuration. Will be taking place. So let's see how the mechanism will follow in SN1 reaction. This is tert butyl bromide. This is nucleophile which is attacking on this substrate. There will be a formation of, the product will be OH, that is tert butyl alcohol, removal of Br minus which is behaving as a leaving group. Okay? So this is the example for SN1 reaction. So the mechanism in this case, this reaction is occurring in two steps. First, in the first step there will be the formation of reactive intermediate is taking place. Okay? First step is a slow step. So this is rate determining step. Rate determining step, it means the rate of reaction is depending upon the first step, in which there is a formation of carbocation is taking place. Removal of Br minus. In this case there is a formation of carbocation is taking place. This carbocation is planar. It means the angle between the each bond is 120 degree. So this carbocation is planar and the formation of this carbocation is taking in the first step. So the rate of reaction is only dependent upon this substrate, that is tert butyl bromide. Second step is fast because this reactive intermediate is highly reactive. So the nucleophile will attack easily on this reactive intermediate, and there will be a formation of tert-butyl. So there will be the formation of tert-butyl alcohol in second step. This step is fast because this carbocation is highly reactive. Both the species are highly reactive. So they immediately form the product, that is tert-butyl alcohol. So the rate of reaction is not dependent upon this step. So the rate of reaction is only dependent upon the first step in which there is substrate. Okay? So the rate of reaction is dependent upon only substrate. So this is the mechanism for SN1 reaction. The SN1 reactions are favored by polar solvent. It means the ionization of this alkyl bromide will be very easy in the presence of polar solvent. Second main thing is that the SN1 reaction will be greatly occur on 3 degree, then to 2 degree, then 1 degree. ठीक है, यानी SN1 reaction will follow in 3 degree. In 3 degree there will no SN2 reaction will takes place. Why SN1 reaction will be taking place in 3 degree? Because of the stability of carbocation. Greater will be the stability of carbocation, greater will be the chances of SN1 reaction. ठीक है, तो in 3 degree there are 3 alkyl groups which are present, okay, which are attached to this carbocation. So the stability of this carbocation will be higher in comparison to 2 degree and least in 1 degree. So SN reaction mostly occur in tertiary carbocation. Why in tertiary carbocation? Because there are 3 donating groups are present. So in this case there is a larger inductive effect and hyperconjugation is taking place. Because of that this carbocation is much more stable in comparison to 2 degree. Whereas SN2 reaction is majorly occur in primary alkyl halides. ठीक है, it is mainly occurring in primary. Why in primary? Because the nucleophile is attacking from the back side. ठीक है, so if the nucleophile is attacking from the back side and there are more alkyl groups, then there will be steric hindrance. So in the case of tertiary, ठीक है, when the nucleophile OH minus will be attacking from the back side, which is the condition of SN2 reaction, then there will be steric hindrance between the OH minus and these alkyl groups. ठीक है, and from the front side it will not attack because there is the same charge present on the both the atoms. ठीक है, so in the case of SN2 it will occurring majorly in 1 degree. Because the steric hindrance will be least from the back side, ठीक है, then in 2 degree and least in 3 degree. ठीक है, और 1 degree से ज़्यादा ये किस में होगा? In methyl. ठीक है, because in methyl case there is no alkyl group is present, there is only hydrogen is present. So in this case there will be least steric hindrance. Second substitution reaction is electrophilic substitution reaction. As you can understand with the term, in this electrophiles are involved. ठीक है, so the example of electrophilic substitution are generally seen in arenes or aromatic hydrocarbons in which benzene ring is present. So first example is when positive charge is present on the chlorine, this will be named as chloronium ion. This is behaving as Lewis acid or electrophile. It is generated by when chlorine is reacting with FeCl3 or AlCl3. This is Lewis acid. So this will react with this chlorine and there will be a generation of electrophile takes place, that is chloronium ion. And this chloronium ion will attack on the benzene ring and there will be a removal of one of the hydrogen of benzene ring takes place. So in the position where hydrogen is present, this chloronium ion will attack, ठीक है, and there will be a removal of H+. Second is example, when benzene ring, ठीक है, is attacked by NO2 plus which is a electrophile, ठीक है, this is nitronium ion. It is formed by when HNO3, concentrated HNO3 will react with concentrated H2SO4. When these two compounds react with each other, there will be a generation of electrophile, which is nitronium ion, and this nitronium ion displace one of the hydrogen of the benzene ring and occupy the position in benzene ring, and there will be a removal of H plus ion. As you can understand with the term free radical, it means there will be the substituent which will be attacking on the substrate is free radical. Okay? So example of this will be when CH4, this is methane, in the presence of chlorine, okay, this chlorine will be attacking on this methane in the presence of light or high temperature heat. There will be a formation of chloromethane, okay, and one Cl will be removed and combined with one of the hydrogen to form HCl. Okay. So this is the reaction. So what will be the mechanism behind this reaction? Mechanism will occur in 3 steps. The first step will be the initiation. In initiation, there will be a generation of free radical will takes place in the presence of light or heat. So in this chlorine, in the presence of light or heat, okay, there will be homolytic fission. Okay, it means the shared pair of electrons are taken by both the atom. This can be represented as, okay, this is the covalent bond. Each chlorine atom will be taking one electron by the help of homolytic fission. So there will be the formation of 2 chlorine free radicals. Odd electron system will be known as free radical. Second step is propagation. In propagation, this free radical, this chlorine free radical attack on the methane. This free radical will attack on this hydrogen. So there will also be homolytic fission because this free radical will initiate homolytic fission. Okay? So there will be a homolytic fission. Removal of H free radical will takes place, and this H free radical will be taken by this Cl. So there will be a formation of methyl free radical and removal of HCl. Okay? So this is methyl free radical. So the propagation step is taking in 2 steps. This methyl free radical then further attack on this chlorine molecule. Okay? So there will be initiation of homolytic fission, and this chlorine free radical will combine with this methyl free radical CH3Cl, generation of again this chlorine free radical. So the propagation step is a chain reaction because in this 2 step there will always be generation of this chlorine free radical. So this step is a chain reaction. So it cannot be stopped till all the free radicals which are generated in the propagation steps are terminated. So next step will be termination. By the help of termination only this chain reaction will stop. Okay? So in the termination reaction, all the free radical are combined in every possible conditions and all the free radicals are terminated. So chlorine free radical can combine with the chlorine free radical to form Cl2. Methyl free radical can combine with the chlorine free radical to form CH3Cl. Methyl free radical can combine with CH3 free radical methyl itself to give ethane. So these are the byproducts which are obtained by termination. In addition reaction, 2 reactant molecules join to form single product, that is addition reaction. The requirement of addition reaction is there should be presence of multiple bond, that is double bond or triple bond. So on the basis of substituent which is attacking on the reactant, that is substrate, is either it will be nucleophile, electrophile or free radical. So addition reaction will be classified into 3 types. First is nucleophilic addition reaction. So first is nucleophilic addition reaction. As you can understand with the term, when nucleophile is involved in the reaction, that reaction will be addition reaction. So the example will be, this is a base, which is attacking on this H plus to form H2O, and there will be the formation of nucleophile. This nucleophile then attack on the aldehyde C double bond OH CH3. This nucleophile will attack on this carbon because this carbon is electron deficient as it is attached to this oxygen. So this bond will be transferred to this oxygen, and this negative charge, that is nucleophile, will attack on this carbon. So there will be formation of CH3, CO minus, CnH. There is a negative charge on this oxygen which will attract this H hydrogen. So hydrogen of this HCN will be removed and attack on this OH minus. So there will be formation of CH3, COH, Cn and H, and there will be removal of Cn minus, that is we will again get nucleophile in this reaction. This reaction is generally occurring in aldehydes and ketones. So the example of nucleophilic reaction is aldehydes and ketones. Second is electrophilic addition reaction. Electrophilic addition reaction, as you can understand with the term, when the electrophile is involved in the reaction, addition reaction, then it will be electrophilic addition reaction. The example of this reaction, when unsymmetrical alkenes are reacted with HBr in the absence of peroxide, then this reaction will takes place. Example, CH3, CH double bond, CH2. This is unsymmetrical alkene, prop-1-ene. When reacted with HBr, this will form CH3, CHBr and CH3. So this will be the formation, and there will be the addition of both hydrogen and bromine. So the mechanism behind this reaction is, in this there is carbocation formation will be taking place. So this reaction will occur in two steps, CH double bond CH2. So the first in this is having positive charge, whereas Br is having negative charge. So in this case, first H plus ion will attack. This will ionize to give H plus ion. So this H plus ion will attack on this CH2 because this bond will be shifted to this carbon. So there will be negative charge on this carbon. This will lead to the formation of carbocation, which is secondary carbocation, that is isopropyl. This is 2-degree carbocation. This is the first step. Second step, there will be attack of nucleophile, which is Br minus. So Br minus will be attacking on this carbocation, the secondary carbocation, and there will be formation of isopropyl bromide, CH3, CH, Br, CH3. There will be the formation of isopropyl bromide. So this reaction is occurring by electrophilic addition reaction. Next is free radical addition reaction. As you can understand with the term, in this the reactive species, reactive reagent which is involved is free radical. This reaction is occur in the presence of generally peroxide. So when unsymmetrical alkene is treated with HBr in the presence of peroxide, then there will be formation of primary alkyl bromide. ठीक है, तो हम यहाँ पे देख लेते हैं what is the mechanism behind this reaction. First, ठीक है, रिएक्शन तो आपको पता ही है, CH3, CH double bond CH2, HBr. There will be, this will be occurring in the presence of peroxide or light. ठीक है, the reaction will form CH3, CH2, CH2, Br. This is 1 degree alkyl bromide. ठीक है, in the previous case, in the electrophilic addition reaction, there is 2 degree alkyl bromide is found, but in this case there will be 1 degree alkyl bromide will be found because of the free radical. ठीक है, तो mechanism behind this reaction, first will be initiation. In the initiation, there will be the formation of first of all free radical, that is odd electron species. So this peroxide is having O single bond O. This peroxide in the presence of light or heat will homolytic fuse, ठीक है, homolytic fission will takes place, ठीक है. This will form two molecule of peroxide, ठीक है. This peroxide then react with HBr, ठीक है. This peroxide react with HBr. So this peroxide initiate homolytic fission in this molecule. So this hydrogen will take its electron, bromine will take its electron, one electron. There will be formation of this H free radical will attack on RO. There will be formation of alcohol and formation of Br free radical. Then second step will be propagation. In propagation, this Br free radical will initiate the reaction. ठीक है. So this will react with this compound CH3 CH double bond CH2. So Br, ठीक है, Br free radical will initiate homolytic fission in this bond. So this carbon will take its electron, this carbon will take its electron. Then there will be the formation of, ठीक है, CH free radical CH2 Br. This Br free radical will attack on this first carbon, ठीक है. So the this reactive intermediate which is free radical, the carbon is having odd electron, is a secondary free radical. Then it will further again react with HBr, ठीक है. So this free radical attack on this hydrogen, ठीक है, and the bond between HBr, this bond will be, this odd electron will be shifted to this Br, ठीक है. So it means there will be homolytic fission, there will be formation of this primary alkyl bromide, that is propyl bromide, and there will be removal of Br free radical. It means this Br free radical will again initiate the reaction, so there will be a chain reaction. So to stop the chain reaction, there should be termination. So next third step will be termination. All the free radical which are formed in this propagation steps are joined in every way to stop this chain reaction. So the product which will be formed, the byproduct which will be formed, Br can react with Br to form Br2, ठीक है. CH3 CH, this is also having a free radical, so either it will react with Br free radical to form CH3 CH Br CH2 Br, or either they will react with each other, CH3 CH CH2 Br. These two molecules, similar molecules, can react with each other to form CH3 C C CH2 Br CH3 CH2 Br, ठीक है. So this is the possible byproduct which will be formed by the termination. Next reaction is elimination. In elimination reaction, there is a removal of two atoms or group of atoms from the same atom or adjacent atom. This is known as elimination reaction. It is classified into three types on the basis of position of atom which is removed, that is alpha, beta or gamma, ठीक है. This is mainly observed in dehydrohalogenation, that is the compound having both hydrogen and halogen, ठीक है. So let's see what are the classification. First is alpha elimination reaction. It means both the atoms, that is halogen and hydrogen, both is present in the same carbon, ठीक है. So this is alpha elimination. It is first, the most common example of this is chloroform. Chloroform formula CHCl3. This is chloroform, ठीक है. In this, in the presence of reagent OH minus, ठीक है, which initiates the reaction, this will attack on this H, ठीक है. So the removal of Cl minus will takes place. It means this bond will be shifted to this carbon, ठीक है, because H will be removed in the form of H plus, so this bond will be shifted to this carbon and in turn this Cl will be removed as Cl minus, ठीक है. So there will be formation of H2O, ठीक है, Cl minus, and this is chlorocarbene, dichlorocarbene, which is having one lone pair of electron, ठीक है. This dichlorocarbene is a reactive intermediate in many reaction, example carbylamine reaction, Remer-Tiemann reaction, which we will be going to study later chapters, ठीक है. So these are very reactive species. It is known as dichlorocarbene, ठीक है. This is alpha elimination. Next is beta elimination reaction. It means there will be removal of atoms from the adjacent carbon, ठीक है. So the example for beta elimination reaction is dehydrohalogenation, ठीक है, and there will be formation of alkene. It is of two types, E1, B, E2, ठीक है. E1 represent elimination unimolecular, E2 represent elimination bimolecular. Let's start with E2, ठीक है, that is elimination bimolecular. The example of this reaction is, in this case this chlorine is present at this alpha carbon and hydrogen of beta carbon will be removed. So this will be known as alpha beta elimination. This reaction is occurring in the presence of base, ठीक है, which is initiating this reaction. So this bond of this hydrogen will be shifted to this side, so the removal of Cl will be taking place. So this will attack on this H plus, ठीक है. ये जो यहाँ पे हाइड्रोजन है, it will be converted to H plus by donating its electron, ठीक है. So this H plus will be abstracted by this OH minus, ठीक है. In transition state, bond length is longer from normal bond length, ठीक है. So this OH is attacking on this H. This will be having partial negative charge, this will be having partial positive charge. Chlorine which is removing is having partial negative charge, so this bond will also be longer from normal covalent bond. So this is representing transition state, ठीक है. Then because this is very unstable, so this further, ठीक है, immediately converted into product, it will form CH double bond, CH2 double bond, CH2, that is alkene, ठीक है. So there will be formation of H2O and removal of Cl minus will takes place, ठीक है. So this is the beta elimination reaction by E2 mechanism. Next is E1 mechanism, ठीक है. E1 mechanism, it means elimination unimolecular reaction. It is similar to SN1 reaction, ठीक है. It is similar, it is showing similar property like SN1 reaction. In this there is the formation of carbocation takes place. Second, there will be the two-step reaction. This is two-step reaction. So the rate of reaction depends upon only one substrate, not on the nucleophile, ठीक है. It is similar to SN1 reaction, so the properties are similar to SN1. So the rate of reaction in E1 reaction is dependent upon only substrate, not nucleophile, whereas in E2 rate of reaction, because it is occurring in single step, the rate of reaction is dependent upon both the substrate and nucleophile, ठीक है. This is occurring in single step, this will be occurring in the two step. In this case there is the formation of transition state takes place. In this case there will be the formation of carbocation takes place. Example, similar to SN1 reaction, this is most probably occurring in tertiary, ठीक है, because the tertiary carbocation is the most stable, ठीक है. So the first step will be of this reaction, ठीक है. This is rate determining step, because in this condition there will be the formation of carbocation is taking place. So this is the carbocation, ठीक है. This is the carbocation, this is the planar structure, ठीक है. This is the planar structure of carbocation. This one of the methyl, ठीक है, this hydrogen will donate its electron to this carbocation, ठीक है. This hydrogen will donate electron to this carbocation. It means the alpha hydrogen, ठीक है. तो ये donate करेगा, so there will be formation. This step is slow, The next second step will be fast formation of CH3, CH3 double bond CH2. ठीक है, this will be the formation and there will be a removal of, because this H, ठीक है, this H will be removed. ठीक है, so this H will be removed because in the presence of OH minus, so this H plus will attack in this OH minus and there will be a removal of H2O takes place. ठीक है, so in this case there is a formation of double bond takes place. This reaction is favored in the condition of carbocation, most stable carbocation. Most stable carbocation is found by the tertiary. So this is the example of SN1 reaction. One more thing is that the OH minus nucleophile which is present here, it is obtained, it is generated from C2H5OH. ठीक है, this is a protic solvent. This will generate this OH minus, ठीक है, which is acting as a nucleophile. The temperature of the reaction is 382 Kelvin. ठीक है, so when you represent this reaction in one step, you have to represent what is the reagent used there and what will be the temperature. ठीक है, so that is one step reaction. ठीक है, next will be gamma elimination. Gamma elimination, there will be removal of atoms or group of atoms from the first carbon of the chain to the third carbon of the chain. This will form a three-membered ring structure. So example of this elimination is this example. As you can see, there are two bromine atom. So if this is represented as alpha, so with this respect this will be treated as gamma. ठीक है, so this bond will be shifted to this carbon. This carbon will become negative, whereas this bromine will take away the shared pair of electron, due to which this carbon will become positive. So there will be bond formation takes place between these carbon. So ठीक है, this is the bond formation which is taking place. It means this bond will be shifted and this bromine will be removed. ठीक है, so when this bromine donates its electron, it will be converted into Br plus and this will be changes to Br minus. ठीक है, so these two bromine react with the zinc dust which is present in the reaction, ठीक है, which is acting as a catalyst. So there will be formation of CH2 cyclic system. ठीक है, three-membered carbon ring which is known as cyclopropane, and the byproduct which will be formed or the removal of molecule ZnCl2. This is gamma elimination reaction. This reaction is also known as a Freund reaction. Next is condensation reaction. In condensation reaction, there is a combination of two or more molecules of similar organic compound or different organic compound with or without elimination of a small molecule like ammonia, water, HCl, ethyl alcohol. So the example of condensation reaction is Aldol condensation, which is shown by aldehydes or ketones. ठीक है, so let's see case. As you can see, there are similar compound of aldehydes are present. This is acetaldehyde. ठीक है, so this reaction is occurring in the presence of dilute base. It means dilute base is behaving as a initiator or catalyst. ठीक है, so what will it do? OH minus will abstract. This is alpha carbon. ठीक है, this is alpha carbon which is attached to carbonyl group. So the alpha carbon hydrogen, that is alpha hydrogen, is abstracted by OH minus. ठीक है, so this will be abstracted by OH minus. So this hydrogen will donate its electron to this CH2. So there will be the formation of carbon ion, because when this hydrogen will donate electron to this carbon, there will be a negative charge coming on this carbon. ठीक है, so the further reaction which will be observed. So when this negative charge is attacking on this carbon, ठीक है, why it is attacking on this carbon? Because this carbon is attached to the oxygen. So this oxygen is attracting its electron, ठीक है, due to which there will be negative charge on this oxygen and positive charge on this carbon. So this carbon ion will attack on this side. So there will be formation of CH3COH. ठीक है, so oxygen will be having negative charge. So which in the presence of H plus form CH3, CHOH, CH2, C double bond OH. ठीक है, so this is beta hydroxy aldehyde. Why it is beta hydroxyaldehyde? Because the aldehydic group is this C double bond O. This is alpha carbon, and at the beta carbon there is OH. So when this compound is heated, okay, when this compound is heated in the presence of acid, mineral acid, there will be removal of hydrogen from this carbon, okay, this alpha carbon, and removal of OH from this beta position. So there will be removal of H2O, okay, and the formation of CH3, CH double bond CH, CHO. This is known as beta crotonal dehyde. Okay, IUPAC nomenclature will be, this is 1 2 3 4 but, okay, 2 enal, okay, but 2 enal. This will be the IUPAC nomenclature. So this reaction is the example of Aldol condensation. Next is rearrangement reaction. In rearrangement reaction, there will be a migration of atoms or group of atoms from one atom to another atom within the same molecule. This is known as rearrangement reaction. So first example is so what will be the name, IUPAC name for this compound? Naming will be done from this position 1 2 3. Okay, so there will be 2, 2 dimethyl propane propanol. Okay, this is the example. Okay, in this case, when the reaction is occurring in the presence of H plus, okay, it is occurring in the presence of some acid which is furnishing H plus, then there will be a formation of CH3, 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 CH2, OH, H. Okay, there will be positive charge on this oxygen. This H plus which is furnished by some acid, this H plus will attack on the lone pair of this oxygen. Okay, because of the attacking on the oxygen, oxygen will be having positive charge. You know that the oxygen is second most electronegative element, so it means the positive charge on oxygen is unstable. So this will abstract this bond towards itself, okay, due to which there will be removal of H2O takes place and the formation of carbocation takes place. This is 1 degree carbocation. Okay. In this case, why it is 1 degree? Because one alkyl group, this alkyl group is present at this carbon. Okay. So this is 1 degree, this is unstable. So there will be rearrangement takes place. Okay. What is rearrangement? 1, 2 shift of methyl will takes place. Okay. From second carbon to first position. ठीक है, तो 1 2 मिथाइल शिफ्ट हो रहा है, यानी एडजेसेंट कार्बन में मिथाइल शिफ्ट हो रहा है, तो देयर विल बी फॉर्मेशन ऑफ CH3, CH3, CH2, CH3. ठीक है, दिस विल टेक्स प्लेस एंड द पॉजिटिव चार्ज विल कम ऑन दिस पोजिशन बिकॉज दिस मिथाइल इज मूविंग टू दिस पोजिशन विच इज 1 2 मिथाइल शिफ्ट. ठीक है, दिस इज टर्शरी कार्बोकेटायन बिकॉज दिस कार्बन इज अटैच्ड टू 3 एल्काइल ग्रुप्स and the stability of tertiary carbocation is very high. This is stable. In this case, because there is a positive charge on this carbon, so there will be alpha hydrogen elimination. Okay, so how many alpha hydrogens are there? First of all, you have to recognize how many alpha carbons. 1 2 3. Okay, so in which carbon there will be displacement of hydrogen will takes place. Okay, this carbon hydrogen, that is alpha hydrogen, will donate its electron to this side. ठीक है, this alpha carbon's hydrogen will donate electrons to this side, so there will be formation of CH3 double bond CH, CH2, CH3. Why it is happening? Why this alpha carbon is donating its alpha hydrogen? Not these are, because this alpha hydrogen when removed, the double bond which will be obtained is highly substituted. ठीक है, अगर आप ये वाला रिमूव करते या ये वाला रिमूव करते तो वो उतना सब्सटीट्यूटेड नहीं होता, तो दिस एल्कीन विल बी मच मोर स्टेबल. Second example of rearrangement reaction is urea. ठीक है, we know that the urea is the first compound which was synthesized in lab by Holler. ठीक है, so how it was synthesized? NH4Cl react with KCNO. Okay, this is double decomposition reaction. In this reaction there will be formation of KCl takes place and NH4CNO, which is ammonium cyanate. Okay, further this NH4CNO on heating will form NH3 and HOC triple bond N. Okay, in this condition there will be rearrangement will takes place. This nitrogen will be having one lone pair of oxygen. So, and this nitrogen will also be having lone pair of oxygen. Okay, so this carbon is electron deficient. So this lone pair will be attacking on this carbon. So this bond will be shifted to this carbon. So the next compound which will be formed, CNH3 double bond, this bond will be shifted to this nitrogen. Okay, so there will be a negative charge and one lone pair. Okay, this nitrogen will be now having positive charge. Okay, this nitrogen will be now having positive charge, whereas this nitrogen now having negative charge. So there will be transfer of proton takes place. Transfer of proton takes place. This will form HOCNH2. Okay, and this hydrogen will be shifted to this side. Okay, double bond NH. There will be one lone pair in oxygen. Okay, next step will be tautomerism. This is enolic functional group. So this is enol isomer, which will be converted into ketonic functional group. It means this hydrogen will be shifted to this side. Okay, this hydrogen will be shifted to this side and double bond of carbon will be formed with this oxygen. Okay, so what will happen next? CNH2 double bond O NH2. Okay, this is urea. Okay, this is ketonic isomer. Next example is Hofmann bromamide reaction. This is named reaction. In this case, the amide is converted into amines. Okay, the amide will be converted into amines and there will be rearrangement of atom will takes place. This reaction is occur in the presence of Br2 and KOH. Okay, so first Br will attack on this side, this hydrogen. Okay, and KOH is having OH minus, so this will abstract this H plus. Okay, so what will be happening? CH3 C double bond O NHBr, one hydrogen is removed to form H2O. Next step will be further KOH will react. This OH minus of KOH will attract this H plus, this hydrogen. So there will be formation of CH3 double bond O N minus, because one lone pair is as it is present. Okay, now there are two lone pairs. Okay, and Br. Now this Br will be removed from this side, this nitrogen, as Br minus. Okay, so the next product which will be obtained is nitrogen will be having two lone pair. Now there will be a rearrangement takes place. This methyl will be shifted to this nitrogen. Okay, this methyl will be shifted to this nitrogen. So what will be the formation? O double bond C double bond N CH3. Now nitrogen will be having one lone pair. Okay, this methyl group is shifted to this nitrogen. Okay, this methyl is shifted in the form of positive, that is carbocation or electrophile. So it will be shifted to this. Okay, and there will be bond formed between C and N, that will be double bond. So this is the formation. Okay, this is alkyl isocyanide. Okay, now in the presence of KOH, hydrolysis will takes place. Okay, hydrolysis will takes place, which will lead to the formation of byproduct K2CO3. Okay, it means this C double bond O will be removed and combined with this, and there will be formation of CH3 NH2, that is 1 degree amine. Okay, so amide is converted into amines. ठीक है, in this there is a rearrangement taking place. This methyl is attaching to this nitrogen, so there is a rearrangement of atoms or group of atoms is taking place. So this is the example of rearrangement reactions. In isomerization reaction, there will be conversion of one isomer to another isomer, whereas the molecular formula both reactant and product will be same, and also the carbon skeleton of both reactant and product will be same. That is isomerization. Example, this is transbutene, transbutene, ठीक है, which will be converted into, in the presence of light, which will be converted to each other, that is cis butene. This is cis butene, 2-butene. ठीक है, next example, first, second, Br, that is bromobutane. ठीक है, bromobutane. In this case, bromine is attached to the first carbon in the presence of catalyst, that is AlCl3, temperature 575 Kelvin. This will change into position isomer. It means this isomer will be changes to another position isomer. It means the position of this bromine will change. CH3, CH2, CH, Br, CH3. This is क्या हो गया ये आपका 2-bromobutane. ठीक है, so this is the example of isomerization. Next is pericyclic reaction. Large number of reactions are not occurred by reactive intermediate, that is ionic or free radical. ठीक है, instead of reactive intermediate there is a formation of cyclic transition state takes place within the reaction, that is pericyclic reaction. There will be formation or breaking of bond takes place simultaneously, and there is no involvement of any catalyst. This reaction is occur in the presence of heat or light. So that some example of this reaction is given as, first, CH2 double bond CH2, CH2 double bond CH2. This reaction is occurring in the presence of light. This is ethene molecule. ठीक है, this is 2-pi system. These both are 2-pi system. ठीक है, so in the presence of light, this bond will shifted to this side and this bond will be shifted to this side. ठीक है, so there will be bond formation between these two carbon and these two carbon. So there will be involvement of transition state takes place. So cyclic transition state will be formed. This bond, which is shown by faded line, showing that these bonds are longer from normal covalent bond. So this is cyclic transition state. This is 4-membered cyclic transition state. So the transition state is unstable, so it will immediately converted into cyclic system. This is cyclobutane. ठीक है, in this 2-pi system is joining to 2-pi system, so it is known as 2+2 cycloaddition. ठीक है, this is known as 2+2 cycloaddition. Second example, ठीक है, this is bond line formula. ठीक है, in this case there are 2 double bonds are present, so this is 4-pi system. And acrylonitrile, this is acrylonitrile, the common name of this system. ठीक है, in this there is 1 double bond is present. This is 2-pi system and also known as dinopyl. ठीक है, this is known as dinopyl. ठीक है, this is 4-pi system, IUPAC name but 1,3-diene. So in the presence of light, this double bond will be shifted to this carbon, this double bond will be shifted to this carbon, and this double bond will be shifted to this carbon. ठीक है, so this bond when shifted to this carbon forms single bond in this position. This bond will be shifted to this side, so there will be one single bond, and this bond will be shifted to this side, so there will be formation of a double bond. ठीक है, ठीक है, these are the 2 bonds which are formed, and this bond is shifted to this side, ठीक है, so there will be, ठीक है, these bond which are representing in the faded line showing that the bond length is larger from normal covalent bond, so this transition state is unstable, which will immediately convert into, and there is also a cyanide group present, ठीक है, in this position, ठीक है, so there will be formation of this compound will takes place, ठीक है. Addition of 4 pi bond takes place with the 2 pi, so this is known as 4 plus 2 cyclo addition. This is also known as Diels Elder reaction, ठीक है. So this is the example of pericyclic reaction. In polymerization there will be a joining of large number of small molecules which can be similar or different. These are referred as monomers. When these monomers combine with each other, they will form large molecular mass compound, that is polymer. So when n number of this monomer, that is ethene, which is behaving as a monomer, ठीक है, join with one another, it will form large chains, ठीक है, having this formula, ठीक है, which is having large mass. This is known as polymer. This reaction is known as polymerization reaction.